Welcome to another video lecture. In this video lecture, we are going to discuss about the example problems on Routh stability criteria. In this first example, we are given with the characteristic equation s cube plus 6s square plus 11s plus 6. Now, before creating the Routh table for this polynomial, let us first draw the pole zero plot. Now, it is not easy to calculate roots of higher order polynomials, as we already discussed in the previous video lecture. I have already solved this equation, and the roots which I found were s is equals to -1, s2 equals to -2, and s3 equals to -3. So, if we will plot the pole zero plot on S plane, we have a real axis sigma, which is the real axis, and the j omega axis, which is the imaginary axis. And if we plot these three roots at s is equals to -1, which is real, on the negative side of the real axis, s is equals to -2, this is s equals to s1 equals to -1, -2, this is root s2, and -3, this is root s3. So, here as we can clearly see that all the roots of the characteristic equation lies on the left hand side of the S plane. This is the S plane. Since all the roots lie on the right side of the S plane, the system is stable. Now, let us verify this with the Routh-Hurwitz criteria. Now, for this, we will create the Routh table as discussed in the previous class. So, for creating the Routh table, we will form a matrix, and we will start from the highest order of the polynomial equation, the s cube. The first row will be s cube, the second row will be s square, the third row will be s power 1, and the fourth row s power 0. Now, the first element of this s cube row will be the coefficient of s cube, which is 1. So, this coefficient is 1, and then we will take alternate coefficient. We will take next coefficient, which is 11, and after this we will take next coefficient, which is 0. And similarly, the second row element will be started with the coefficient. Let me erase this. Next coefficient will be the coefficient of s square, which is 6. Next coefficient will be the coefficient of s to power 0, which is again 6, and the next coefficient will be 0, since there is no other terms. The first coefficient of s to power 1 row here, let us assume this coefficient will be a1. So, since we have already discussed how to calculate a1 is equals to, let me write it here, this will be 6 multiplied by 11 minus 6 multiplied by 1 divided by 6. So, let me write it here, 6 multiplied by 11 minus 6 multiplied by 1 divided by 6. So, this will comes out to be 66 minus 6 divided by 6, 60 divided by 6. So, it comes out to be 10. So, let me place this and write here the exact value, which is 10. Now, similarly, this second element, suppose this is a2. So, a2, I am writing this calculation here, a2 is equals to 6 multiplied by 0 minus 1 multiplied by 0 divided by 6. So, let me write it here, a2 is equals to 6 multiplied by 0 minus 1 multiplied by 0 divided by 6. So, this comes out to be, since all the numerator term are 0, so this will comes out to be 0. So, a2 is 0. Similarly, the a3 will also be 0. So, this is 0, this will also be 0. Now, the next term, let us assume this term to be b1. So, b1 calculation, as we discussed in the previous class, it will be 10 multiplied by 6 minus 6 multiplied by 0 divided by 10. So, let me write here 10 multiplied by 6 minus 6 multiplied by 0 divided by 10. So, this will comes out to be 60 divided by 10. So, it will be 6. So, let me write here, this will comes out to be 6. Now, this coefficient, last coefficient s to power 0 will be the last row element of the Routh table. Now, if you can see that all the columns, all the coefficient of the first column are positive, there is no sign change in the first column, let me write this statement here. There is no sign change in the first column, hence we can say that system is stable. As we already discussed in the previous lecture, that number of sign changes in the first column is equals to number of roots on the right hand side of this S plane, and since there is no sign change in the first column, hence there are no roots on the right side of S plane, hence the system is stable. Let's take another example. F of s equals to s cube plus 4s square plus s plus 16. Let us again first draw the pole 0 plot for this polynomial. If you will calculate the roots of this polynomial, you will find that the roots are equals to s1 is equals to minus 4.55, s2 is equals to 0.276 plus 1.85j. You will get complex roots for this polynomial. S3 is equals to 0.276 minus 1.85j. So if you will plot these roots on the pole 0 plot on the S plane, this is real axis, this is j omega real imaginary axis, and if you can locate the poles on this S plane, the first root is S1, which is minus 4.55 negative real root. So let us assume that this root is at this position S1, which is at minus 4.55. The next root S2, which is a complex root, the real part is 0.276. Let us assume that this point here is 0.276, and imaginary value is 1.85. So let us assume that this value here, it is 1.85. So this root will be like here on the S plane, S2. Similarly, on minus 1.85, the next complex conjugate root S3 will lie on the negative side of the imaginary axis. So here we can see that two roots S2 and S3 lie on the right side of the S plane. Hence, we can predict from the pole 0 plot that the system is unstable. Now let us verify this by the Routh Hurwitz method. Now let us create the Routh table for this particular characteristic equation. We have highest order of this polynomial is S3. So we will start with the S3, S to power 2, S to power 1, S to power 0. The first coefficient will be coefficient of S cube, which is 1. The second coefficient will be coefficient of S, which is also 1. Third coefficient is 0. Similarly, the first coefficient of S square row will be coefficient of S to power 2, which is 4. The next coefficient is the coefficient of S to power 0, which is 16. Third coefficient will be 0. Now, we have already seen how to calculate the remaining coefficient. Let us assume that the first coefficient is A1. So A1, I am writing here, A1 is equals to 4 into 1 minus 16 into 1 divided by 4. So this is 4 into 1 minus 16 into 1 divided by 4. So this comes out to be 4 minus 16 divided by 4, which is minus 12 divided by 4 is minus 3. So let me write this as minus 3. Similarly, this second coefficient A2 will be, I am writing here, A2 will be 4 into 0 minus 1 into 0 divided by 4. So this will comes out to be 4 into 0 minus 1 into 0 divided by 4. So this will comes out to be 0. So the remaining coefficient will be 0, 0. Now the first coefficient of S to power 0, which is again comes out to be, let us assume this to be B1. So I am writing here B1. B1 equals to minus 3 into 16 multiply by minus 4 into 0 divided by minus 3. So this will be 16 into minus 3 minus 4 into 0 divided by minus 3. So this comes out to be 16. So B1 is equals to 16. So now if you will see in the first column, the first element here is 1, the second element is plus 4, third element is minus 3. So there is one sign change from minus 4 to minus 4 to minus 3. There is one sign change, and then again minus 3 to 16. There are two sign changes. So there are two sign changes in the first column. Hence, there are two roots on the right side of the S plane. So the system is unstable. I hope you understood these two problems. Thank you.